Greetings, Earthlings. Hope all is going well in your chemical reactions chapter so far. You've learned how to balance reactions, and you've also learned how to write in word equations now. So now we need to get a little more specific here into different types of chemical reactions. So as you can see here at Fremont, we cover 5 general types of reactions, and really most high school classes will, but we'll break these up a little bit so it's not overwhelming all at once, but today we'll cover synthesis reactions and decomposition reactions. And in those names, it really tells us a lot about those types of reactions. When we look at synthesis reactions, I mean, the word synthesize truly means to make or make something new. So, for instance, a lot of times a synthesizer is a piano type instrument where people make up new sounds in music. If somebody has a synthetic limb, usually that's something that's man-made that we had to make in a lab. You'll know it's a synthesis reaction because usually, not always, but almost always, we'll have several reactants to start with, and usually we'll just make one final product. So, an example of this, maybe get out a blank piece of paper and do this one with me here, but this is what we do in class normally. A great example of a synthesis reaction is this. Beryllium, we know is an alkaline earth metal, reacts with oxygen to form what? So maybe get out a piece of paper and follow along with me here, but a lot of kids will jump and make a lot of simple mistakes on this one. So the first thing we kind of do is we go and look at what we're dealing with here, and this is going to be kind of messy on my PowerPoint, but we have to think about if beryllium is by itself, are we going to go write it with a +2, or are we going to go write it with no charge? And the answer is we're going to go write just Be, because it's only +2 if it's in a compound, meaning it's lost those 2 electrons, and it will only lose them if it's with something else. Likewise, oxygen will just be by itself here because it's not in a compound, and this has a little bit of a trick, but we know when these two things come together, I mean, I just have one element plus another element, they're going to come together to form a compound, which is what our first unit in chemistry is all about there, and we know once these are in a compound, beryllium will always have a charge of +2, and oxygen will always have a charge of -2. So I think it gets a little bit messy here, but what I'm going to go right here then, this is transferring my synthesis reaction from a word equation to a chemical equation, and we probably see a few things we struggle with. We're just going to have these dashes in front because that always reminds us that we need to go balance it after. It's not something you have to do, but it seems like when I've had classes put the dashes, they don't make simple mistakes. We have just Be by itself because it doesn't have a charge yet because it's by itself, and think about why do I have a 2 right here? This oxygen is by itself, and we know anything that's a gen by itself is diatomic. So what this means is I'm going to go probably burn some beryllium and combust it and burn it in oxygen. And when they come together, a lot of kids would think this is BeO2. But we know the subscripts over here are determined by the charges. In a compound, beryllium's +2, oxygen is -2, so we just need one of each, and that right there is a neutral ionic compound. With my dashes, I remember I have to balance, and what I see here, I always want to start with my metals, but I have 1 beryllium and 1 beryllium. I have 2 oxygens I'm starting with, so technically I have to end with 2 oxygens, but I can't go make a subscript, so what do I have to go do? Is put a coefficient right there. And now I have 2 berylliums, so I need to go fix that I have 2 berylliums. Now it's all balanced. It's a synthesis reaction because I took 2 elements and made one new thing, and the answer to the blank would be beryllium oxide. Remember, we dropped the ending and add IDE. So there's a really good example. Let's go do one more example together as a class here. Another great example with this would be copper 1 oxide reacts with water to form what? So again, that's our word equation, and we know it's going to be synthesis. We'll kind of talk about that as we go here, but we know the Roman numeral is the charge, so copper oxide is a compound. We already know what water is, so we got to do some crisscrossing here, but how I'd get this set up then would be Cu2O, because I have to crisscross to get my stable compound, plus water makes something here. Now, ultimately, I wouldn't expect you guys, or Mr. McMahon wouldn't, to go and know what this is. So you'll have to go use your reactions help sheet, and I'll make another video showing you about that. But what we go look up here is that what we have is a metallic oxide. Now, that sounds scary, but this is a metal, it has oxygen, so we call it a metallic oxide. If you go look on your reactions help sheet under the synthesis box, it says that a metallic oxide plus water always makes a metallic hydroxide. So we know since it's only making one thing, that's what synthesis reactions do. And now we don't know what it is, but we know that whenever these two things mix, they make a metallic hydroxide. And a lot of kids will say, well, how do I know what that is? Well, guys, the metal was copper plus 1. The metal over here with hydroxide is going to be copper plus 1. So if I go kind of redo that math right there, I know that that's what my product's going to be because of my chem guide and what it's telling me. So I crisscross charges, and now we have our whole complete chemical equation. This is synthesis because it's just making one new thing. We remembered to put our dashes to make sure it's balanced. I can see over here, I always start with my metals. I start with 2 coppers, so I need to, oops, I guess I didn't balance this one. I need to end with 2 coppers. Then that would make me have 2 oxygens, which is great because I have 1 oxygen here and 1 oxygen here, so oxygen's good. And then I can see I started with 2 hydrogens, which is great because I have a 2 right here, showing me I have 2 hydrogens. Synthesis reactions will always end in one thing. On the opposite end of the spectrum, a decomposition reaction is almost the exact opposite. To decompose means to break something down. If I hit a deer on the side of the road, the body decomposes and breaks down into its original parts. Decomposition reactions usually only have one reactant on the left side of the arrow, and it breaks down into many more. So get that piece of paper out and let's do this one together here. Magnesium nitride decomposes. I know this would be a decomposition reaction because it says the word decomposes, and we just need to be problem solvers here. I know in this compound it's not just going to be Mg, it has to be Mg plus 2 because that magnesium is part of this compound. Nitride is not one of my polyatomics. It's not 8 or ite, it's ide. So what I need to do here then is go crisscross and realize this 3 has to come down and this 2 has to come down. And here's my magnesium nitride reaction. A lot of times you'll see a little triangle over the arrow. That means we heat it. And if we heat this up, we know that it's going to break down. Now a lot of kids will say, well, how do I know what this breaks down into? But that's a pretty easy question, guys. If we have magnesium and nitrogen together, what's it going to break down to? It's going to break down into magnesium and nitrogen. And a lot of kids want to just go put Mg plus N, but we know that's not correct because now that it's by itself and it decomposed, it's nitrogen, and we'd have to have that as a diatomic molecule. I don't think I put dashes on this one, but we can see over here that if I start with 3 magnesiums, I need to end with 3 magnesiums. I end with 2 nitrogens, and I start with 2 nitrogens. So that is an example of a decomposition reaction because I start with one thing. Sometimes there's a triangle because I heat it up and it breaks down into its parts. Let's do one last one here. Another example of a decomposition one is barium chlorate is heated. A lot of times when we apply heat to something, that will decompose it into something stable. So I got to go write my charges and symbols. So I know barium's plus 2. Hopefully you guys have your polyatomic ion sheets. We can look up that chlorate is ClO3 with a -1 charge. So I got to crisscross and make sure I'm careful. That 2 shows I need 2 of those parenthesis chlorates right there. And I know if it's heated, it's going to break down into something. Now, this a lot of times kids will struggle with because they might just say, well, this breaks down into barium, this breaks down into chlorine, it breaks down into oxygen. And that just doesn't look right. There's no way that that's right. So what we instead have to go do is use your chemistry guide again, or your reactions help sheet, and we can go look up. There are helps and hints that tell us what this would break down into. Barium is a metal, that's chlorate. So if you go look on your reactions help sheet at the decomposition box, it will tell you that anytime you decompose a metal chlorate, what it will break down into is a metal chloride plus oxygen. So now we just have to be problem solvers. What's our metal here? It's barium. Chloride is just chlorine, and that's part of a compound, so it's -1, and then we'll have oxygen by itself here. So my new product will be barium with chloride, and if I go write all that out, here's what barium chlorate will decompose into. You'll always be able to use your reactions help sheet, but you still have to crisscross and figure out your charges. Last but not least, it's oxygen because it's diatomic again by itself there. Now I need to go balance it. If I went and did that, I'd see that I have 6 oxygens right off the bat right here because I have to multiply. So there should be a 3 in front of this oxygen. Then I have 2 chlorines. I have 1 barium, and I have 1 barium. That'd be good. Decomposition always starts with one thing. Usually synthesis ends with one thing. Go get after it on those practice problems and make sure you take your time and use your reactions help sheet.